Hello, welcome to the FRQ of the day. So today we're doing the 2016 number 5. So let's read this together, and then if you want to give this a shot, that would be great. So this one says a polling agency showed the following two statements to a random sample of 1,048 adults in the United States. Environmental statement: protection of the environment should be given priority over economic growth. Economy statement: economic growth should be given priority over protection of the environment. The order in which the statements were shown was randomly selected for each person in the sample. After reading the statements, each person was asked to choose the statement that was most consistent with his or her opinion. The results are shown in the table below. So 58% picked the environmental statement, 37% predict the economy statement, 5% had no preference. Part A, assume the conditions for inference have been met. Construct and interpret a 95% confidence interval for the proportion of all adults in the United States who would have chosen the economy statement. Part B, one of the conditions for inference that was met is that the number of those who chose the economy statement and the number who chose and the number who did not choose the economy statement are both greater than 10. Explain why it is necessary to satisfy this condition. And part C, a suggestion was made to use a two-sample z-interval for a difference between proportions to investigate whether the difference in proportion between adults in the United States who would have chosen the environmental statement and the adults in the United States who would have chosen the economy statement is statistically significant. Is the two-sample z-interval for a difference between proportions an appropriate procedure to investigate the difference? Justify your answer. So give that a shot. Pause the video, give that a shot. Okay, so the first thing in regards to part A, it asks us to construct and interpret a confidence interval proportion. So that would be a z-interval, and it says that the conditions for inference are met. In other words, the assumptions are met. And so you have to do the other three parts of the TAME acronym. Whenever you're asked to construct a confidence interval, you should do the TAME acronym. The type of inference, you have to say that. The assumptions, which is the conditions, which you don't have to do here because it says to assume it. And then the mechanics of making the actual interval, and then the ending, which is your conclusion and context. So for that, the first thing for part A is that you state what you're doing. I'll create a one proportion z-interval. So, and of course you don't have to check the conditions, which would be sin, which are met here, by the way. But there's the construction of the interval. And so, once again, on your formula sheet, the formula for the interval, confidence interval, every confidence interval, statistic, plus or minus critical value times the standard error statistic. Statistic, in this case, is p hat. It's always going to be p hat or x bar, or the difference in p hats and the difference in x bars of a two-sample thing. The critical value is z star here. It'd be t star if we were doing with a mean. And then the standard error of the statistic. Well, what's that? You go to the next page, the standard error statistic. We're working with a proportion here, and so it is that. That's for the one sample. This is for the two-sample interval. That's for the two-sample test. And, of course, these are for the means here. But we're dealing with that situation. So that's how I get the formula. That is our p hat. That's our sample proportion. That, of course, you can get off table B. Or you can get it off your calculator using inverse norm, and then there's the formula for the standard error. So when you find that, that's of course the margin of error. That's a popular question. What's the margin of error? It's always critical value times that, and there's our interval. Now, all you have to write down in this situation is the interval. Okay, but you need to understand what I said in regards to the formula. Let me remind you how to do this with your calculator. So with your calculator, what you would do is you would go stat, you would go test, and you go down to one proportion z-interval. So one proportion z-interval is option 0. That's 2. One proportion z-interval. So one proportion z-interval is option A. One proportion z-interval, which is the 11th option. So you go that. And so in this case, we have, so in this case we've got, 37%? So our x bar is going to be 0.37 times 1,048. Okay, now it has to be an integer. X has to be an integer, so in this case you'd round it to 388. 388, that is our number of successes in our sample, and then 1,048 like that. And so that was our sample data in essence. All right, 95% confidence like that, and so there we go. And so there's our interval. It's a little bit off of this because of round off, error, but anyway, as long as it's close, it's fine. But that's all you had to write down in regards to the mechanics. And of course, your ending, you're going to say, I'm 95% confident that this interval captures the parameter, which in this case is P, and if it was a mean, it'd be mu, all right? And then you say what the parameter is. It is the proportion of all the adults in the U.S. who would have chosen the economy statement, and word it like they worded it. So they worded it, the confidence interval for the proportion of all the adults in the United States who would have chosen the economy statement. So so there you go. And so that's a, kind of a stock one proportion Z interval, and you didn't have to do the assumptions, which was sin. Anyway, and so then it asks, all right, so then it asks this. One of the conditions that was met is that the number who chose the economy statement and the number who chose who did not choose were both greater than 10. And why is it necessary? And that is our normality condition, is that n times p hat. So part B is that to do a one proportion Z interval, n times p hat and n times 1 minus p hat both have to be greater than 10. All right, so that the sampling distribution of all possible values of p hat will be approximately normal. If you just said, so we need this for normality to be met, they would have given you credit. Okay, they would have given you essentially correct. If you just said, so that the normality is met, you would have been given credit. But this is the more complete way of saying it, and this is the way it would be worded in a multiple choice question, is that normality means the sampling distribution of all possible values of p hat would be approximately normal. And what it's talking about, and so n times p hat is the number of successes, by the way, in the sample. In other words, it's the number who would have chosen the economy statement. And n times 1 minus p hat is your number of failures. So that's the number that did not choose the economy statement. So you just basically had to say so that normality would be met. And then the other thing is, someone suggests to do a 2-sample Z interval. So why is it not proper to do that? And that gets at the concept of independence. This is just one sample here. And so this is what I said, no, in order to do a 2-sample Z interval for the difference in proportions, there needs to be 2 independent samples taken. There was only one taken here, all right? There are not independent samples taken here. It is just one sample. The more people select one statement, the less they will be selecting the other statement. And that is the concept of independence. Independence means the occurrence of one value is associated with a change in the occurrence of the other value, and that would be happening here. I mean, this is just one sample. If you have a lot of people pick the environmental statement, it would mean that you're not going to have a lot take the economy statement, so you don't have independence. In order to do a 2-sample thing, you have to have independent random samples. So what you would have to, the minimalist answer there, make sure and answer the question that's being asked. You would say, no, you can't do it because we don't have 2 independent samples here. That would be the quickest, in essence, way of saying it, but this is the more complete way of saying it. All right, there you go. Look, let me remind you once again on these problems, if you're getting half of it right, you're doing really good. If you're getting a 2 on each of these problems, okay, a 2 on each of these, then that means you're borderline between a 3 and a 4. So, don't be discouraged if you're missing part of this. When you encounter a problem that you really are unsure about and you don't know how to do, try to just write something down that's going to give you some credit. But anyway, that's it. And so, okay, so you did so good today. You get a little Reese's cup. That's right. And you get, another smiley face. So you get a bunch of them. There you go. I hope you have a fantastic day. I look forward to seeing y'all again tomorrow.